Let's have our lecture video in integral calculus with the topic integration of rational fractions. The second one, repeated linear factors. For some applications, we need to integrate rational expressions that have denominators with repeated linear factors. That is, rational functions with at least one factor of the form ax plus b raised to n, where n is a positive integer greater than or equal to 2. If the denominator contains the repeated linear factor ax plus b raised to n, then the decomposition must contain a sub 1 over ax plus b plus a sub 2 over ax plus b raised to 2 plus until it reaches a sub n over ax plus b raised to n. We will stop here because we already reached the power of n as indicated here. Now a1, a2, and a sub n are all constants that needs to be determined. But before we proceed to solving, we need to arrange the factors in ascending order first. Okay, so let's exercise this by solving examples 1 to 2. Okay, let's integrate number 1. We have here the integral of dx over x times x plus 2 squared. So first we need to rewrite. So rewrite this first. This is 1 over x times x plus 2 squared equal to a over x, this one here, plus, so since we have used from the previous video a, b, c as the constants, we will copy that in this example. Although in the lecture we use a sub 1, a sub 2, but we can still use a, b, c, and d as constants. Okay, so here b and the denominator here is x plus 2. So we are proceeding in the ascending order. So this one here is c over x plus 2 squared. Now we will stop here now because we have reached here the power of 2, which is the value of n here in the original denominator. Okay, then we will multiply both sides with the original denominator x times x plus 2 squared. So if we multiply this with the left portion here, so we will cancel out the denominator. So what's left is 1 equals, multiply this with the first term on the right side, we will cancel out x. So what's left is a times x plus 2 squared plus, multiply this with the second term on the right side, we will cancel out x plus 2, the first or the 1 x plus 2 there. So what's left will be bx x plus 2. Then we have c, multiply this with the third term, cancel out this one here. So what's left is c times x. Now if we want to get the value of a, so from the previous video we learned that we have two methods in determining the values of the constant. So I will choose substitution. Substitute x is equal to 0. So we have here 1 is equal to a times 0 plus 2 squared plus b times 0, 0 plus 2 plus c times 0. So we will cancel out b and c. So what's left is a. So we have here 1 is equal to 4a. Therefore, a is 1/4. So next is we will try to get another value by substitution. So we can get the value for C if we substitute x with negative 2. We substitute x with negative 2, we have here 1 is equal to a times negative 2 plus 2 squared plus b times negative 2 plus 2 plus c negative 2. So cancel this one out because it becomes 0. So what's left is 1 is equal to negative 2c. Therefore, c is equal to negative 1/2. Then, to get the value for b, we cannot use substitution. Rather, we can just use the method for equating. So, substitute, distribute. So, we have here 1 is equal to, from this, let's distribute a. This is a times x squared plus 4x plus 4 plus bx squared plus 2b x, 2bx, okay, plus cx. Then we have here 1 is equal to ax squared plus 4x plus 4ax. 4ax plus 4a plus bx squared plus 2bx plus cx. Then, let's equate x squared. So we have here 0 equals a plus b. So we have here a and then b. Then, knowing the value for a, so we already have a value for a as 1/4. So we have here 0 is equal to 1/4 plus b. Therefore, b is equal to negative 1/4. Okay. So now we were able to find the values for a, b, and c. Now let's proceed to solving this. We need to go back, rewriting that. The integral of dx all over x plus 2 squared is equal to the value of a. What's the value of a? That is 1/4. So we have here 1/4 integral of dx over x. For b, we have negative 1/4. Then integral of dx over x plus 2. Then we have the value for c as negative 1/2. Integral of dx all over x plus 2 squared. Then let's solve that one by one. So this becomes 1/4 ln of x minus 1/4 ln of x plus 2 minus, this is 1/2. Then we will use powers here. So x plus 2. This is actually raised to negative 2 plus 1. So negative 1 all over negative 1 plus c. So final answer is 1/4 ln of x minus 1/4 ln of x plus 2 plus 1 over 2 times x plus 2 plus c. Okay. So if you can simplify it further, then that's okay. I can still accept this as the answer. So that's for number 1. So screenshot first before we proceed to the second example. Okay, for number 2. For number 2, we have integral of x plus 1 dx over x squared x minus 1. So this is repeated again because of this part here. We write. So we have here x plus 1 over x squared x minus 1. That is equal to a over x plus b over x squared. And then stop it there because there's no longer c over x raised to 3. So since this is 2, we stop at 2. Then let's add the distinct linear here. So we have x minus 1. Multiply both sides with x squared x minus 1. Multiply this to the left side. It will cancel out. So what's left will be x plus 1 equals, multiply this to the first term in the right side. So we cancel out x. So what's left is a x times x minus 1 plus, do it with b. So what's left there will be x minus 1. For c, we have cx squared. So x plus 1 equals ax. So I'm not gonna use the substitution method. So I will just distribute it. Ax squared minus ax plus bx minus b plus cx is squared. Then let's equate x squared. So we have here a and c. So we have a and c. So we have there 0 equals a plus c. So c is equal to negative a. Equation number 1. Then equate x. So we have here x negative ax plus bx. So we have here 1 equals negative a plus b. That is equation number 2. Next, let's have equate constants. So we have constants 1 minus b or negative b. So 1 equals negative b. So b is equal to negative 1. Having the value for b, substitute b to equation number 2 to get the value for a. So we have there 1 is equal to negative a minus negative plus negative 1. So that is equal to, we transpose a here. So we have a equals negative 1, negative 1. So a is equal to negative 2. Then substitute a to equation 1. So we have here c is equal to negative 2. So c is equal to positive 2. Okay, finally we have the 3 constants needed for this. Let's rewrite that. So integral of x plus 1 dx over x squared x minus 1 is equal to value for a. So we have there negative 2 integral of dx over x. Value for b, negative 1. So negative dx over x squared. Value for c positive 2 dx over x minus 1. Then, solve them one by one. We have negative 2 ln of x minus, this is power formula here, x negative 2 plus 1, negative 1. Negative 1 plus 2 ln of x minus 1 plus c equals negative 2 ln of x plus 1 over x plus 2 ln of x minus 1 plus c. Okay, so that is the answer. Then you can still further simplify that. It's okay. If you have this as an answer, then I still accept this. So let's screenshot first before we proceed to the last example number 3. So that is number 2. The last example, number 3. So we have here integral of x raised to cube minus, or x raised to 3 minus 12x plus 4 dx all over x squared minus 3x plus 2 squared. So quite difficult, but you need to see first if we can factor this. Okay, so we have there x squared minus 3x plus 2. So we multiply here negative 1 and negative 2. If we add this, we have negative 3. Okay, therefore the roots are x minus 1 or x minus 1, x minus 2. If you can have it x minus 2, still okay. Okay. And that is, since it is squared, so this is squared, therefore this is also squared. Therefore, we can rewrite this as x raised to 3 minus 12x plus 4 all over, the factor here is x minus 2 squared times x minus 1 squared is equal to a over x minus 2 plus b over x minus 2 squared. Then stop. Then proceed with the next one, c. X minus 1 plus d x minus 1 squared. Then stop. Then multiply both sides with the original denominator, which is the x minus 2 squared times x minus 1 squared. Multiplying this to the left side of the equation, it will cancel the denominator out. So what's left will be x raised to 3. Okay, so I think I need to save some space. So x raised to 3 minus 12x plus 4 equals, so multiply this with the first term, it will cancel out x minus 2. So what's left will be a x minus 2 x minus 1 squared plus b, cancel out x minus 2, so what's left will be x minus 1 squared plus c, so x minus 2 squared times x minus 1, and then d x minus 2 squared. Okay. Then we have here x raised to 3 minus 12x plus 4 equals, distribute, ax minus 2a. Then this one here is x squared minus 2x plus 1 plus b x squared minus 2x plus 1. Next, lower part, plus c. So we have here c x minus c. Then we have x minus 2 squared. So we have the x squared minus 4x plus 4 plus d. We have x squared minus 4x plus 4. Okay, so we need to be very careful on this one. One mistake, even in the sign, will make our final answer incorrect. So we have here x raised to 3 minus 12x plus 4. Let's do this as organized as possible. Let's have the first one, the a. Constants a. Distribute constant a. Ax raised to 3 minus 2ax squared plus ax minus 2ax squared plus 4ax minus 2a. So that's for constant a. Next, let's go to b. Constant b, we have there bx squared minus 2bx plus b. So that's for b. Let's go to c. Plus cx raised to 3 minus 4cx squared plus 4cx minus cx squared plus 4cx minus 4c. Next, we have d. Constant d. X squared minus 4dx plus 4d. Okay. Then, we need to simplify further. X raised to 3 minus 12x plus 4, combine like terms. We have here ax raised to 3. Like terms are this one. Okay. So we have the negative 4ax squared plus 5ax minus 2a. For b, we have there bx squared minus 2bx plus b. For c, we have cx raised to 3 minus 5cx squared because of these terms plus 4cx, so 8cx minus 4c plus dx squared minus 4dx plus 4d. Okay, now we will use this final part here in equating. So equate x raised to 3. So we have here x raised to 3, x raised to 3. So we have 1 equals a plus c. So c is equal to 1 minus a. That is equation number 1. Next, equate equate x squared. So we have here 4, negative 4, positive 1, negative 5, and positive 1. 0 equals negative 4a plus b minus 5c plus d. This is equation number 2. Next, equate x. So we have there negative 12 equals, for a we have 5a. For b we have negative 2b. For c we have positive 8c. Then for d we have negative 4d. This is equation number 3. Equate constants. We have here 4 equals the constant negative 2a. The constant for b is positive b. Constant for c is negative 4c. Constant for d is positive 4d. That is equation number 4. Yes, it's very, very long. Okay, so what will we do here? We will eliminate as much as possible the other unknown so as to have one unknown left. Okay, using these equations, what can we eliminate first? Let's eliminate d. So if we want to eliminate d, let's add equation 3 and 4 because it will cancel out d. So equation 3 and 4. Let's focus on equation 3 and 4. We have there negative 12 equals 5a minus 2b plus 8c minus 4d. For equation 4, we have 4 equals negative 2a positive b minus 4c plus 4d. Cancel out d. So what's left is negative 8 equals 3a minus b plus 4c. Let's name this as equation number 5. Next, what can we eliminate next? So let's eliminate c. If we want to eliminate c, what will we use? So we need to eliminate another d so as to have c only. So if we want to create another equation which have a, b, and c only, then let's focus on equation 2 and 3. Equation 2 and 3. So as to get the equation with 3 unknown a, b, and c. So 2 and 3, equation 2 and 3, we have there 0. 0 equals negative 4a plus b minus 5c plus d. Then we have equation 3, 12 equals 5a minus 2b plus 8c minus 4d. To eliminate d, we will multiply the equation 2 with 4. We will multiply it with 4 so as to transform as 0 equals negative 16a plus 4b minus 20c plus 4d. Then copy the equation 3. Negative 12, 5a minus 2b plus 8c minus 4d. Then we will cancel out 4d here. Then what's left will be negative 12 equals, this becomes negative 11a plus 2b minus 12c. So this becomes equation 6. Now finally, we have two equations with three unknowns, and we can now eliminate C. So let's focus on equations 5 and 6. So we have here negative 8 equals 3a minus b plus 4c. And we have negative 12 equals negative 11a plus 2b minus 12c. Then to eliminate c, let's multiply equation 5 with 3. So we have here negative 24 equals 9a. Let's move it further for aesthetics. Plus, minus 3b. Okay, so we have here so let's have here, and let's continue with this one. So I'm a bit, so we have there plus 12c. So we have here negative 12 equals negative 11a plus 2b minus 12c. Cancel out c. So what's left here will be negative 36 equals, this is negative 3a, negative 2a. This is minus b, and that is equation number 7. If we use this as equation 7, actually, we can shorten this one out, because if we are looking for two equations with two unknown, that means, so that means we will eliminate again. But since we already have an equation here with two unknowns, C and A, might as well use that one, right? So we will use equation 1 for finding the value of A. So what we need to do actually in equation 5 and 6 is not eliminate C, rather we need to eliminate B, because the unknown for equation 1 is A and C. Okay, so let's have a more faster solution by eliminating eliminating B. So instead of multiplying by 3, what we need to do here is multiply equation 5 with 2. So multiplying it by 2, we can eliminate B. So I did not see it immediately, but at least we can use this as a faster way to solve this. So this is negative 16 equals 6a minus 2b plus 8c. Then we have negative 12 equals negative 11a plus 2b minus 12c. Then b here will be cancelled out. So what we have here is negative 28 equals negative 5a minus 4c. That is equation 7. Then, having the value for, or having here, c is equal to 1 minus a, we can just substitute 1 to 7. So we have negative 28 equals negative 5a minus 4 times 1 minus a Negative 28 equals negative 5a minus 4 plus 4a. So negative 24 equals negative a. So a is equal to 24. So having the value for a, we can have the value for c. If we substitute a to equation 1, c is equal to 1 minus a, which is 24. Therefore, c is equal to negative 23. Okay? So having the value of a and c, where can we use these values? In what equation can we use it? We will choose from the equations with 3 unknowns. So we have equation 5. We can use equation 5 here. Or we can use equation 6. But since this equation 5 is simpler, let's use that one. So that is negative 8 equals 3a minus b plus 4c. So substitute a and c to equation 5, which is negative 8 equals 3 times a, which is 3 times 24, minus b plus 4 times c, which is negative 23. Negative 8 equals 72 minus b minus 92. 92. So b is equal to, so you can use your calculator or you can do mental math here. So b is equal to negative 12. Having the values for a, b, and c, we can now choose from the equations of 4 unknowns to substitute this value to get the value for d. So let's find something simpler here. Okay, this one. Let's use equation number 2. It's much simpler having d only here. So that is 0 is equal to negative 4a plus b minus 5c plus d. So substitute a, b, and c to equation number 2. So 0 is equal to negative 4a plus b, negative 12, minus 5c plus d. Then using your calculator or solve it mentally, you have the value for d as negative 7. So finally, we have the values for a, b, c, and d. We need to rewrite. We have here integral of x raised to 3 minus 12x plus 4 dx all over, what's the denominator again? So we're using this one. We're solving this already. So going back there, the original denominator is x squared minus 3x plus 2 squared is equal to the value of a, 24, integral of dx over x minus 2, then b, negative 12, where is it? Ayan, b, so we have there dx over x minus 2 squared. The value for c is negative 23, dx over x minus 1. Then for d here is negative 7, integral of dx over x minus 1 squared. And let's solve them one by one. So here we have 24 ln of x minus 2 minus 12. Power formula, we have x minus 2 raised to negative 1, minus 23 ln of x minus 1, then negative 7 power formula x minus 1 negative 1 over negative 1 plus c. Then final answer, we have 24 ln of x minus 2 plus 12 over x minus 2 minus 23 ln of x minus 1 plus 7 over x minus 1 plus c. So that is the answer. Okay, so that's for number 3. So you need to rewrite this in your notebook to provide solution for the given examples. Okay, so that's all for this video.